Good morning. We would like to thank you for the organizing committee of International Conference on Statistics, Mathematics Teaching and Research, or ICSMTR, for giving us opportunity to present our work through the recorded video. Let me introduce myself. My name is Fahmi. I'm one of the authors, together with Mr. Bayhaki Sregar, Mr. Asmina Sution, Mr. Rukman Aldin, also Ms. Ufi Andayani. Our work, entitled Soil Moisture Monitoring System Using Wireless Sensor Network. Let me start the presentations with the introductions. The soil is a medium for growing a variety of plants. The soil is composed of mineral and organic matter that is very vital of the life on Earth, because the soil supports plants by giving the nutrients and water, as well as the support of the roots itself. Measuring the soil of moisture manually, usually done by using the tensiometer. This is not only not practical, but it also takes a long time. Therefore, in our research, we try to propose an automatic monitoring system of soil moisture by using wireless sensor network. Let me show you the general architecture of our systems. The system itself consists of several parts. The most important part is the hardware part, that consists of the sensor, the WASP mode board, and also the XBS, the communication module. The data gained from the sensor will transmit into the internet that will be saved in the database in the server, that can connect to the client, that can give the notifications and also report of the sensor reading to the time. Here, our method developed as follows. The data we use derived from the sensor that should be calibrated, because the sensor itself measures the humidity, the moisture, in the frequency of hertz. This is need to be converted into a percentage, since the conversion is needed in agriculture field. The researchers measure the moisture by percentage instead of the frequency. So the first step of the method is to calibrate the sensor reading. The second step is by the collecting of the data. It's plant the sensor in the bucket contained of a depth of 40 centimeters from the top of the bucket. With the embedded sensor, the main WASP mode board will hold the data with the digital pins and then stored into the micro SD in TXT format. We can also monitor through the XB gateway with the standard of IEEE 82.15.4 that will communicate with on the main WASP mode. The data from the micro SD that can be translated from the researcher by removing from the memory card from the WASP mode board and then collected into the card reader. The data obtained and stored is still in the form of frequency. And the last method, in the embedded sensor in the soil, watering is done until the soil reaches field capacity conditions and reach the saturation point, where the soil cannot hold any more water, so that the water will flow off the lower place. This data then will be collected for a couple of days, and from this data collections we will obtain the lowest frequency point, the highest frequency point for the calibrations. This is the flowchart of the notification system that we developed. As you can see here, is a requirement of the parameter sensors. When it's exceeding below or lower than or bigger than the threshold parameter we set, it will trigger the notification systems. It is important for the system to let the researcher know if the moisture of the soil is below the targets or up the targets. So the notification system that we built here is one of the main important part of the system. This is one result that we measured from the actual plants during 3 days of analysis. Here we can see we can get the real-time data of the soil moisture get from the sensor plant inside the bucket. Based on the results on the first, second, and the third test, the percentage seems to increase in soil moisture percentage, is strongly influenced by the water given the soil contained in each container. The response of the detections in the test indicate that the sensor and the system are running well. If we want to increase the percentage of moisture quickly, we have to give the water into the container in a large volume, and also as quick as possible. As far as the rate of the percentage, the decline is strongly influenced by the level of evaporations. Evaporations takes a long time to evaporate water from the soil. When observing the level of moisture decline, we require a notification that will let the researcher know when they left the soil with high humidity and they want to monitor the soil moisture percentage. The researcher can simply set the level of humidity that he wants to be monitored. As long as the applications give the data and the moisture content of the soil is equal or smaller from the point set by the researcher, then the system will immediately provide notifications. And this is possible since we utilize the XP module for communications. From the system, we have concluded of our work that the rate of a percentage increase in data readings by sensors concerning the soil moisture conditions tend to increase faster depending on how much water volume is given to the soil. It indicates that the performance of the sensors and the monitoring system goes according to the process of infiltration of water into the soil, and we can conclude that our system runs well in this case. The rate of the moisture, the gradation in data regarding the sensor readings tends to be slower, as this depends on the evaporation process occurring in the soil. Evaporation, as we can know, depends on the temperature, also the environment of the bucket. The faster the evaporation process will decrease the soil moisture in the faster way too. But however, the evaporation process is slow, then the percentage decline will be slow as well. This rate of percentage decline will require a notification system. That in this case, the researcher should set a parameter that can set parameter limit to be monitored by the researchers. We also find out in our test of our result that the notification system is working properly. That can give information to the researcher about the condition of the soil moisture. I think that's all for our presentations. We would like to invite for your questions and comments through our email that you can find in the conference book. Again, thank you very much for your attention, and also for the committee that giving us this chance to make a presentation of our works. Hope can see you in the next conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.